Welcome guys to today's keep solving our physics GRE31, and hope we can go through it without obstacles. So 31 said that the first 5 harmonics produced by organic pipe at both ends, and if we close one end, then which one is will survive. So remember that basically when two ends are open, the wave looks like this. So the smallest is lambda over 2. The smallest wavelength which L can contain. So basically the frequency is the speed over lambda over 2L. Speed over lambda. So basically this is 2L. So the possible frequency is this. It means from 1 to 2 to 3. And then when one end is closed, then this is the first one. And then the second one is this. So basically, you can show that this Fm is m nu divided by 4L, but m need to be 135. So from the previous, this result tells us that nu divided by 2L is 50. So nu divided by L is 100. So this Fm is 25m, and equal to 135. So we have 25, 50, 50, 75, 125, 175. So when we close that way, we see where it's where these 5 coincident with this. Unfortunately, there are none of them coincident with this. Okay, so none of it survive. The answer is E. The study said that reflecting telescope considered to converting lens separated by 100. So basically, this tells you the focus of these two lenses sum is 100. And you know the eyepiece contains 20, and the object piece is 80. And so the magnification telescope basically is just object over eye. So it's 4. The answer is A. Okay, and the 33, the best type lasers. Let's just ask about the common sense. So you don't have, you need to remember the answer is A. The answer is A, because this is tunable to the visible range. Okay, 34 rod measures 1 meter in the red systems. How fast it must observable moves. So you know that the lens should be contraction. So basically the nu is and you want it 0.8 equal to 1 times this. So you solve V is equal to 0.6 C. It's 0.6 C. So the answer is special relativity. The answer is B. Okay, 35. The particle decays to mu. Basically, this is also special relativities. The time will increase by this factor. Okay, so basically, decays to microsecond. Micron should be microsecond. Okay. The same particle move at the 0.6 speed of light. Then a lab how far I travel in the lab before it decay. Okay, so special relativity, basically we need to first solve this delta t prime. Basically, it's just this. By the way, gamma, we use gamma is this. So basically, delta t prime is gamma t delta t, and we know that gamma is when v is 0.6, and this is gamma is 1 over 0.8. So this is 1 over 0.8 times 2 to the negative 6. And basically the distance it travel is the speed of light, speed of not speed of 0.6 c times this one. And then you c is equal to 3 times 10 to the 8. So the answer is this one, 450. So the answer is D. The answer is D. The 36, the rest of mass particle with total energy, momentum, approximate. Basically, this is also special relativity. All you need to remember is E squared equals to B squared C squared plus M squared C to the fourth. But now all of energy is transformed into the GeV over C. So when the notation looks like this, because now you see the this is P to first, so P to square, because this M is this momentum is already turned to GeV over C. So basically we have 5 squares equals to 5 squares is the total energy, and 4.9 squared plus M squared. So we can solve M is close to basically this is point. Okay, so M squared is 0.1 times 9.9. Which M is close to 1? GeV over C square. Because this is C to the fourth, so this is C squared. So the answer is D. The answer is D. Okay, 37. If a charge Q is located at space at point x equals to 1, y equals 10, z equals to 5. Okay, so it's somewhat complicated. We plot the graph in order to see the carefully. So x is 1, y is 10, z is 5, probably here. And what is the total electric flux passed through the YZ plane? So YZ. Okay. So in the test, you don't have time to do the integral. Okay, so there's no impossible to do the integral, and this integral is not easy to do. You will get some arctangent, or I guess. So but you know that separate into these two parts, then from symmetry that your charge is here, so the flux into this just basically the same as the whole space. They just divide all the space into two. So all the flux is Q over epsilon, and the half is just Q over 2 epsilon, and only 2 over Q epsilon is the possible answer, because you know that at least it cannot be infinity, and it cannot be 1, and it cannot be 0. So the only reasonable answer is D. Okay, and 38. Let's think about there's a Q in this. Okay, I hope I should draw it much carefully. So that's why I study physics and math, but not the arts, because I cannot draw a circle very good. Due to my Q. Okay, so I try to draw it quickly. Oh, sorry. Oh, nice, but not very okay. So this is A, this is B. So you guys pretend it is eccentric overlap. Okay, so and then charge Q is placed on a conducting shell, so you have some conducting shell. So basically this is conducting. So there means no electric field here. And ask about electric potential. Basically we know that the electric field outside this, from the Gauss law, you know that this is this one. And then you know that in the infinity, the voltage is 0, the potential is 0. So remember that the VA minus VB is equal to minus A integral B due to dE times the integral. Okay, so V A is let me okay. So this is R hat. So let me set VA is infinity and VB is B, and this is minus infinity B to Q plus Q divided by 4 pi epsilon not R square dr. Okay. So this is 0, and we have V of B equals to minus Q plus Q for pi epsilon R square, no R square R, infinity to B. And when infinity plug in, you get 0. When B plug in, you get B. So V of B is Q plus Q for pi epsilon naught B. And then basically this is the answer because there's no electric field between A and B. So the answer is E. Answer is E. Nice. So 39, basically you have some electron and two proton, and which force is largest and which one is smallest. So basically you have electron, proton, D. Okay, so basically to solve it quick, we can use some notation. So basically FD is proportional to 1 over basically all of 1 over D square, and is this direction, and this also not so, and this F larger D is proportional 1 over large D square, and this and also this direction. So the first choice in the first diagram, the answer is FD plus FD. Okay, and the second diagram basically is E is here and P is left. Okay, and there's a P. So the second one is this one. So second one is FD minus F of larger D. And the third one basically is the Pythagorean principle. So it's 1 square root. Oh shit. It's a square root F of D plus larger F of D squared. So you can easily see that this one is the largest, this is the middle, this is the second. So this is the third. So 1, 2, 3. So the answer is F1 larger than F3, larger than F2. So the answer is C. The answer is C. So I think everybody knows why this is. If you don't know that, you can plug any FD. Maybe you can say this is 3, this is 5, this is 3, and you can easily get which one is correct. Congratulations. So number 40. Unfortunately, number 40, you need to remember a formula. If you don't remember a formula, you need to solve it by yourself. The formula is basically the this one. And you also know that the V root mean square need to be I root mean square times Z. So basically Z is the impedance. So basically remember, so the total so the effective resistance is R plus JW, J omega. So basically this J is just the imaginary part in the electric circuit because I is coincident with the current. Okay. Not really. So omega C minus 1 over omega L minus 1 over omega C. So the Z is a known of this one. So known of this one is R squared plus R squared plus WL minus W omega C squared. Okay. And so these two are the things you need to remember. And basically, the third one you need to remember is that the usual definition of the of the power is basically is I squared times R. But average you need to use the average you need to use the root mean square. Okay, so basically we have these three. Okay, so we can write it as, so basically you can see this VR mass is this one. So basically you can change this. Basically this is the answer. Because that I already said that this is R, this is the imaginary part, and this is phi. So basically, z times cosine phi is equal to R. This is a almost a definition. So if you remember this formula, yeah, you can get answer A. If you remember this formula and this formula, you can use this definition plug in, and you get the cosine phi equals to R over Z, and you can use this. You first plug into V, then you that the Z times cosine phi become R. So if you remember these two or these two, then you can get the answer. The answer is A. So if you forget about this formula, then you need to solve it by yourself, and probably it's difficult. Okay, so the answer is A. So this is our 30 to 40.